Hello, in today's lesson we're going to look at some examples that involve box and whisker plots and their applications. So on a box and whisker plot, 5-dot summary, we have these 5 points that represent the median, the upper quartile, the greatest value, the lower quartile, and the least value. And when we put 5 dots out there, those 5 dots create 4 sections or 4 quartiles. And within the box, half of the data is in the box, 1/4 on each side of the line. We have 1/4 of the data in each whisker. So we have 4 sections, 4 quartiles, each containing 25% of the data. So sometimes you'll see this referred to as quarter 1. First quartile has 25% of the data. The second quartile has 25% of the data. The third quartile has 25% of the data. And the fourth quartile has 25% of the data. So this allows us to answer a bunch of questions about how the spread of our data is, how much of our data is contained in each of these 4 sections. So like if you're have a math test, you really want to be in the 4th quartile. You want to be in that top 25%. It would be a sign of struggling if you're in the bottom quartile. So we kind of get a feel for 4th quartile being our highest scores and 1st quartile being our lowest scores. But at box and whisker, we can talk about each of these percentages and the amount of data that fall within the variability of our data sets. So we have the interquartile range of a data set is the difference between the 3rd quartile and 1st quartile. It represents the range of the middle half of the data. So we're talking about like the top of the box minus the bottom of the box, or the upper quartile minus the lower quartile will give us the interquartile range. And that talks about the middle of our data, or that middle 50% of our data, as the interquartile range. So I want you guys to pause the video here and take this set of data and answer these 5 questions. All right, welcome back. So the first thing I would do with these is I would order them from least to greatest. Putting them in least to greatest makes it much easier to spot all these medians, lower quartile, upper quartile. So the median for the whole set of the data, the number in the middle, 19. We had 2 numbers in the middle. We could add them up, divide by 2, we get 19 because they're both 19. Median of the lower half. Median of the lower half is also referred to as the LQ, 16. The median of the upper half, or UQ, 21. And then we have our extremes. The highest and lowest numbers on our data set are 13 and 25. Lastly, we have what is the interquartile range? Well, the interquartile range was our UQ minus our LQ, or in this case, 21 minus 16, and we get 5 for the interquartile range. So these 5 points would be how we'd make a box and whisker plot. We would use these 5 points above a number line, and we would create our data display. Okay, we have a double box and whisker. We have 2 sets of data to compare. We have math test scores from 2 classes are shown on the box plots below. We have period 1 shown in blue, and below that we have period 2 shown in black. So let's look at some questions that we might be asked based on 2 sets of data. So which class had the highest score? Well, I can find the highest score up here out on the whisker. I have highest score in period 1 looks to be 100. Highest score in period 2 looks to be 95. So by 5 points, period 1 had the highest score. They had at least one 100. Which class had the highest median score? Well, I can find the median of both sets of data in this middle line in the middle of each box. So period 1 has a median score of 60. Period 2 has a median score of 65. So period 2 is greater than period 1. Period 2, 65%, was higher than period 1 at 60%. What percent of students scored above 65% in period 2? Well, 65 is right here in the middle, so that would be 50% below that, 50% above that. So 50% of students would have scored above 65%. What percent of students scored below 80% in period 1? All right, 80% is here. That includes this quartile, and this quartile. So since I have 3 different quartiles, 75% of the students would have scored below an 80. So if period 1 has 30 students, how many students scored less than 60%? Well, we know that 50% score above 60, 50% score below 60. And so if it's 50% that are less than 60 and there are 30 students, half or 50% of 30 students means 15 students would have scored below 60. So we're using each of these quartiles, each of these 4 sections, knowing that there's 25% of data in each quartile to answer each of these questions, and then we're given an actual number of students. Then we can find the actual number of students in each of those sections discussed. All right, here's a chance for you guys to try one. Compare the 2 data sets and use the box and whisker plots to compare the medians and range of the 2 data sets. I'm going to let you guys pause the video here and make 2 statements about the medians and ranges. All right, welcome back. So if I'm looking at the medians of the 2, data set A has a median at 18, data set B has a median at 16. So data set A is 2 higher. And then if I look at the ranges, that's kind of the size of the whole box of whisker. I can see right away orange has a larger range, and actually it's larger by 2. It's 2 bigger. So then I can make a statement about both of these, such as data set A has a greater median by 2, and data set B has a greater range by 2. All right, I want you guys to pause the video here, take a minute and compare the 2 sets of data and identify a box and whisker plot for the given data. All right, welcome back. Let's see how you did. Both box and whiskers look very similar. The only difference I see is this upper quartile number. This one has an upper quartile at 20. This one has an upper quartile at 22. This would also be referred to as the 3rd quartile. So our 3rd quartile is different. I put the numbers in order from least to greatest. Then when they're in the order from least to greatest, I can spot that my upper quartile is 20. Well, this one is 22 and this one is 20, so we must have the data for data set B. Data set B matches with this graph. All right, last one here. I want you guys to pause the video, answer those 6 questions, come back. We will see how you did. All right, welcome back. We have, what is the median number of runs? Well, the median number of runs is right here in the middle of the box. That is 4. What percent of games had scores 4 runs or more? Well, 50% above, 50% below the median, so 50% of our games would be more. What was the most runs scored in a game? Well, we have this point right out here at 8, so 8 would be the most scored in a game. What percent of games did they score less than 2 runs? That would be this bottom quartile here, would be 25%. If they played 30 games, how many games did they score 4 or more runs? Well, 50% of the games they scored 4 or more, so 50% of 30 games, 15 games. And lastly, what percent of games did they score 6 to 8 runs? Well, that is that 4th quartile, that is 25% of the games. So I hope that helps you guys with your applications of box and whisker plots. Have a great day. OUT spells out.